In the last lecture we have seen basic operational concept. Today's topic is instruction formats. Means the types of instructions depending on the number of addresses. So according to the address there are 3 address instruction, 2 address instruction, 1 address instruction, 0 address instruction and 1.5 address instructions. So we will see this one by one. First is 3 address instructions, in which there are 3 addresses apart from the opcode. So the syntax is opcode, address 1, address 2 and address 3. So the example of this 3 address instruction is like this: add z, xy. So this instruction is having a 3 addresses: zxy, zxy, zxy. Okay, so what is this instruction? This instructions add x and y and store the result in z. Similarly, this sub instruction subtracts y from x and store the result of subtraction into the z. So here there are 3 operands, and 3 operands are used for the operations, arithmetic operations. Okay, so this is the 3 address instructions where there are 3 operands. Then 2 address instructions. For the cost reason, these 3 address instructions are not used in many machines, so 2 address instructions are introduced, in which there are only 2 addresses. So the syntax is first opcode, then address 1 and address 2. So this instruction is having a this format is having a 2 addresses. So example of this is add xy. Means this instruction adds x with y and store the result in x. So this instruction adds x with y and store the result in x. Similarly, sub xy, this instruction subtracts y from x and stores the result in x. Okay, then move xy, this instruction moves the y into x. So like this, there are only 2 addresses in the instruction. So one is source and other is destination. Then one address instructions. As for the cost reason, 3 address instructions are replaced by 2 address instruction, and the 2 address instructions are replaced by the 1 address instruction on where there is only 1 address. Okay, so the example of this is add x. So here for the 1 address instruction, one of the operand is in accumulator, the special register which is provided in the machine, that is called as the accumulator. So one of the operand is stored in the accumulator and result is also stored into the accumulator. So the one example of this 1 address instruction is add x, means this instruction add x with the accumulator and it store the result into the accumulator. So one of the operand of the operation is in accumulator. Okay, then sub x. So this instruction again, it subtracts x from the accumulator and it store the result into the accumulator. Okay, then mul x. So this mul x instruction multiplies x with accumulator and store the result in accumulator. Likewise, then load x loads the x into accumulator, store x, store the accumulator into x. Okay, so these are the 1 address instructions. Then 0 address instruction. So 0 address instructions are not having any operand. Okay, there is only opcode for the 0 address instruction. Basically these are used for the stack, where the 2 operands are known to us. Okay, so the two operations which are performed on the stack is push and pop. We have to push the data on the stack and pop is used to retrieve the data from the stack. So when we push the data on the stack and we want to add that elements, then we are using this instruction add. So this add is not having any operand. When it is performed on the stack, then this instruction adds sp, means stack pointer, with sp plus 1. Okay, so for example, if sp is 7th location, so it adds the 7th location with the 8th location. Okay, and store the result in 7th location. So this is the zero address instructions. Okay, again the zero address instructions of our 8086 are this: STD, set direction flag; CLC, clear carry flag; STC, set carry flag. So these instructions are not having any operand, so these instructions are called as the zero address instructions. Okay, then one and half address instruction. So here the one address is always refers to the memory location and other is into the register, so that is called as a one and half address instruction, in which one operand is memory location, one operand is in memory location and second operand is in CPU register. So that is the one and half address instructions. Okay, so the next topic we will cover in the next lecture.